I'm Professor Jason Donoff. I teach physics and energy issues at the University of Calgary in Canada. I am also the chief editor for EnergyEducation.ca. Please check us out. We're quite proud of the work we do there. I'm also the official mad scientist for Tyche Books, a Canadian science fiction and fantasy publishing house. I also suggest you check out Tyche Books. This series of talks was put together for the Canadian Nuclear Society and International Nuclear Science Week. I hope you enjoy our exploration through science fiction and science fact. The 20th century was astounding by any reasonable standards. The societal, scientific, and technological changes that happened were breathtaking. In a few decades, we went from the Wright brothers at Kitty Hawk in 1903 to successfully landing a man on the moon in 1969. We went from the horseless carriage through the Model T, where we have mass production of automobiles, to drive-in movies. We went from a calculator being a person who makes calculations in a room full of people who all make calculations, to a room full of electronics. And these electronics make the calculations. Those electronics got smaller and smaller and smaller until we eventually had a pocket calculator that you could carry in your pocket. And now a calculator is something that you have on your phone. It is almost impossible to wrap our minds around how much this technology has changed how we as people interact with the world. But one illustrative story: my own grandfather was a telegraph operator for the Romanian Railroad, back when the information superhighway was a single copper wire spreading between towns. Before he died, he and I had played chess by email. I lost. In 1911, Tom Swift electric rifle, TASER, was an electric rifle that was proposed that was later developed in 1969 into the taser. Now, of course, Tom Swift's electric rifle was not the original electric rifle. You originally had Leyden jars, which were explored in Jules Verne's 20,000 Leagues Under the Sea. I would be remiss. Okay, I'd be ridiculous if I didn't talk about Star Trek. So, the NCC 1701, the USS Enterprise, right next to it, you have the USS Enterprise. Yes, an aircraft carrier was actually named after a spaceship in a television show that ran from 1966 to 1969. Despite its short run of only 3 years, Gene Roddenberry's creation has influenced science and technology in profound ways. Let's talk first about the technology itself. The communicators became flip phones. Why? Because the people working on the flip phones were like, I want to make a communicator. The tricorders are now functionally smartphones. In fact, I am aware at the University of Washington of a fair amount of work that's going into making apps that will allow people to do at-home diagnosis. And the conclusion is, he's dead, Jim. Jesting aside, what we can say is that Star Trek is something that everybody in STEM winds up being familiar with. My English teacher in high school made the comment that you have to study Shakespeare because all educated people know Shakespeare, quote Shakespeare, use words from Shakespeare. It's true, I'm not denying that. But for people who are working in science, technology, engineering, math, these people, these geeks, okay, yes, I'm a geek. I wouldn't be doing this video if I wasn't a geek. These geeks know Star Trek because it's an important part of our culture. We geeks wind up relying on Star Trek as a common story that all of us share. James Doohan got an honorary PhD from the Milwaukee School of Engineering. He was shocked. I know nothing about engineering. But the Milwaukee School of Engineering said, but you have inspired so many people. You have given voice through the character of Scotty to a generation, and I would say every generation, of engineers that have come after that. Now, of course, you can learn about this in a documentary called I'm Working on That, How William Shatner Changed the World. And the original book that William Shatner wrote, I'm Working on That, A trek from science fiction to science fact. In 1942, Robert Heinlein, writing under the pen name Anson MacDonald, his middle name and his mother's maiden name, wrote a story called Waldo. Now, at the time, in that story, Waldo himself is a crippled genius who is so brilliant that he has lost his humanity and interacts with the world through what are known as telefactoring devices, which we now, amusingly, as you can see in the picture, in the 1970s, are now calling Waldos based on the story. Waldo, though, is more than just a prediction of these ability for robotic arms to work in factories and so forth. It is once again a conversation about how we can lose ourselves if we have too much technology around us. And it is, in a way, a meta-story, because it is a story about how humanity needs that connection through other stories and other people. Sometimes there's an interplay between the story and the technology. So hand dryers actually were patented back in 1921 as a freestanding structure that people would plug in. In 1940, in the story Coventry, Robert Heinlein has hot air blowing out of the wall as a way of people drying their hands after they wash it off. And then it turns around in 1948, hot air hand dryers wind up becoming popular. So sometimes the technology exists, but it needs to get popularized in people's imaginations before it will wind up being accepted. Or sometimes the technology just needs to improve enough to be economically viable. Some ideas from science fiction, like this idea from Time Enough for Love in 1973, is not a good idea. In Time Enough for Love, the main character, Lazarus Long, is attempting to deliver a baby using gravity. He specifically has a foot pedal that he pushes down on, which winds up increasing the pull of gravity at the right moment during the delivery of the baby to make the delivery easier. Robert Heinlein was a brilliant man and had many good ideas. This was not one of them. However, in 1977, as you can see here, someone took out a patent on doing artificial gravity-induced childbirth by strapping a woman who's giving a baby down to a giant rotating table with a foot pedal that speeds up the rotation of the table at the right moment to allow the baby to come out more easily. Fortunately, nobody, to my knowledge, has been dumb enough to actually try this. Please don't try this at home. Robert Heinlein's classic children's book from 1948, Space Cadet, which as a kid I loved. The problem with Heinlein is it's harder to love Heinlein as an adult than it is as a child. But he predicts atmospheric braking, which, as we see here from 1991, is something that's actually used. So what is it? When you deploy a satellite from the Earth, you have to send it at a really high speed to another planet like Mars. You then need to slow down the relative velocity of the satellite and the planet. You can use the drag forces in the atmosphere to do that. So the satellite goes into the atmosphere, and the atmosphere winds up slowing it down, and then you can actually come out of the atmosphere again to go into a stable orbit. This is something that was predicted in a children's book in 1948. Why I loved Heinlein as a child. It was also used in 2001 by Arthur C. Clarke, which is much easier to love as an adult. Switching over to Isaac Asimov, in 1952, Foundation and Empire, Isaac Asimov predicts the existence of little handheld nuclear generators. Radioisotopic thermal generators are a real thing, and as we see here, in 2012, the Curiosity mission to Mars, the SUV-sized rover, is powered by plutonium, by this radioisotopic thermal generator that had been predicted back in 1952 by Isaac Asimov. And not just the Curiosity mission, a number of other missions, for example, the New Horizons mission out to Pluto a few years after this, was also plutonium powered. So we have a plutonium powered mission to Pluto. It's almost like a gag from the underworld. Going forward, what we're seeing is that NASA doesn't have access to enough plutonium-238. We are dealing with an actual plutonium shortage. That, to the best of my knowledge, has never been predicted by science fiction. We'll talk more about the Foundation books, which got the Hugo Award for the best science fiction series of all times, in a future video. But one other device that we had, a tool if you will, that came out in a book in 1953, and I can't find when the first automatic ticket machine was. But we now actually see automation taking over for people, something that science fiction had predicted. Geosynchronous satellites are satellites whose period matches the rotation of the Earth. They're roughly 7 times the Earth's radius away, and we don't use them all that often. We usually have satellites that are a lot closer. But Herman Potočnik wound up proposing this back in the 1930s in a nonfiction essay inside of Science Wonder Stories. You have to understand that in the early days of science fiction, and even to some extent today, science fiction and science fact are presented alongside each other. So the young minds who are being inspired by science fiction are actually getting a dose of real science. Arthur C. Clarke himself wrote first about space elevators, something that could extend from the Earth out to these geosynchronous satellites. Now keep in mind, the space elevator would need to be 7 times the radius of the Earth long. So Arthur C. Clarke, being an amazingly brilliant man, sat down and worked out, we would have to have the molecular strength of the bonds between carbon atoms. So he proposed back in the 70s that carbon nanotubes would be used to build a space elevator, something that people are still looking at today. I strongly recommend checking out Fountains of Paradise. It's a wonderful, wonderful story. It was also used in Robert Heinlein's 1982 book, Friday, and the more recent book by probably the most popular science fiction author alive, John Scalzi's first big work, Old Man's War. What we see is that science fiction is giving us this hope for the future, something for us to aspire to. Arthur C. Clarke was remarkably prophetic. In addition to the carbon nanotubes that you see here, he also predicted molecular sieves. This would be a molecule shaped in such a way to go through seawater and harvest the raw elements that are just diluted in our seawater. In recent years, Japanese scientists have actually come up with these molecular sieves specifically to harness uranium out of the ocean. As Jim Conca pointed out in a Forbes article a few years ago, in some ways, this makes uranium, which powers our nuclear power plants, a renewable resource, predicted by Arthur C. Clarke. Arthur C. Clarke also predicted personal interest profiles, functionally Google Alerts. This is an example of, rather than a mechanical thing like a hairdryer, but a computer process that is doing our work for us. Now, Aristotle wrote about mechanized workers for us thousands of years ago. And in the next video, what we're going to explore is how science and technology have given us workers that will wind up doing our heavy lifting for us, and occasionally even our thinking for us.